Okay, so today we are going to be looking at section 3.3, working with simplifying algebraic expressions. So one of the big things to take away from this section, and it's just a generality with the nature of working with expressions versus equations, is that we're not going to always get numerical answers when working with these things. So up till now, as we had it on the chapter 2 material, we had a little bit on the test, we'd work something out to get x equals 9 or x equals 25 or -3, something to that effect. So this section is to get us more introduced to the idea of we are not going to always have just numerical answers. We're going to have a lot of instances where our answers are actually going to contain variables within them. And that's okay, depending on what we are being asked to do. So this section is primarily focused in on working with those. How do we work with those? What's our answer going to look like? And the types of answers that we can be seeing moving forward with this kind of a section. So we have some properties that we want to go through. And again, these should look fairly familiar in the sense of we worked with these back in chapter 2. I can't remember the exact, it was 2.2, 2.3, and maybe a little bit of 2.4. But our commutative property of multiplication, our associative property of multiplication, and our distributive property. We also had negating the sum, and again, all of the previously learned properties, and all these ones are still going to be applying the exact same way. So again, our commutative property tells us if I have everything multiplying together, it does not matter the order that I list them in. So A times B is the same as B times A. If you want to put some numbers to it, 2 times 3 is the exact same as 3 times 2. Looking at our associative property, if I have 3 things multiplying together, A times B times C, our associative property tells us I can group these things together however I want to. So I can work with multiplying A times B first, and then multiply by C. Or I could say I want to multiply B times C first, and then multiply by A. So we can multiply these things in any order that we want, or we can group them together in any order that we want. And our distributive property, again, just some refreshers here with these, tells us that if I have A times the sum of B plus C, it's the same as saying A times B plus A times C. This A distributes through to both terms inside of the parentheses. Same idea if I had subtraction going on inside the parentheses. If I have A times B minus C, I'm going to get A times B minus A times C, our final answer. So again, either way you want to write it out for yourself. If you want to have the times multiplied or written out in there, that's fine. If you want to leave it as AB plus AC or AB minus AC, this form is implied that A and B and A and C, the way it's written, are multiplying together. So this implies multiplication. AB says A is multiplied by B, AC is A times C, so on. And again, as another reminder for this, remember that the distributive property does not apply to exponents at all. It only applies when I have things multiplying together. It has absolutely no influence, no bearing in any way, shape, or form on exponents. So if you ever apply the distributive property when I have something raised to a power, to the second power, the third power, fifth power, whatever, we cannot distribute an exponent through. If you do that, you're going to lose a lot of points on the homework. You're going to lose a lot of points on the test. It's just wrong. You can't do that. Our next one that we have, negating a sum. So if we have the negative, the opposite of the quantity A plus B, we can think of this negative out front as having an invisible 1 that's attached to it. And then we could apply the distributive property in that regard. So a -1 times A, it's going to give me negative A. -1 times positive B, it's going to give me a negative B. And our other scenario that we have, just as an example with it, negative A minus B, well, okay, a negative times a positive, it'll give me a negative. A negative times a negative, it's going to give me a positive answer. So just changing the signs there, each of these. Okay. So again, all of these properties that we have here, all the previous properties that we've learned for adding, subtracting, we have multiplication here, and our division rules are all still going to apply to this section as well. So if you need to go back and reference the notes from chapter 2, there's nothing wrong with that. Do it if you have to. We're still going to be using those. Now, as we have here, when simplifying algebraic expressions, PEMDAS remains as the guideline for what we do and in what order we do them. Again, the name at the top, simplifying. It's got our buzzword of simplify written in there. That's going to tell us PEMDAS is coming back all over again. So if we are not comfortable with PEMDAS, or not sure on how to use that, I'll tell you right now, PEMDAS is not going away on this homework. It's not going away on the next test. It's not going away on all future tests you have. It's not going away on all future classes that you take with math. PEMDAS is a very, very universal thing. We learn it very early on in math. It's not going away. So if you're someone who is struggling with that, you absolutely need to get that nailed down for yourself. Okay? It means doing some extra problems if you need to, referencing the textbook examples that are listed on our WAMAP course. It means taking a look at maybe making up some problems for yourself if necessary. And if need be, coming to maybe the office hour or at the end of class when I ask everyone, are there any questions that we need to go through regarding the material from the lecture notes or otherwise? And if that means you want more practice with PEMDAS, that's the time to ask me. It's the time to get that help with it, because it's not going away. All right, so we're going to take a look at a couple of these examples here, and then we might go on to some of the a little more challenging ones that are on the next page. That would be designated as group problems, but I think it can't hurt to go through and see more of these at once. So these are the 4 examples I'm going to reference first, but we're going to jump over to the whiteboard and take a look at things over there, or actually work through them a bit more. So jumping over there. There we go. Okay, so the first example that we had, that we were given, oops, get the mouse here, there we go. So again, we were told to simplify. And our first example that we had, that we were asked to simplify down, we had the quantity of negative 4x times 3y. And again, simplify, that means I'm doing PEMDAS. Again, if you're someone who is comfortable with keeping track of PEMDAS in your head, you don't need to have all of this written out for yourself. Great, good for you. I like having it written out more often than not, just to keep track of where I'm at, what I'm doing. So again, going through PEMDAS, I can't do anything inside the parentheses. I can't simplify just negative 4x down at all. I can't simplify just 3y down at all. So done with parentheses. I have no exponents. I need to multiply and divide. I have parentheses next to each other, which implies that these two things are going to multiply together. So a negative 4x times 3y. So I can multiply the numbers together. Negative 4 times 3. A positive times a negative is going to give me a negative. 4 times 3 is 12. Get that there. Now I have x times y. Okay, I can't really combine those things together any further because they are different variables. So the best I can do in our final answer is just writing everything out multiplied together. Negative 12 xy. So it's implied that all 3 of these things, the number, the x variable, and the y variable, are all multiplying together, the way it's written out. And that's all that we can do. It's the best we can do to multiply things out. Okay. So we'll take a look at our second example from that group of 4. So we have the quantity 2x times negative 7y times 3x. Okay. So like we saw with the properties that we had, we have three things multiplying together. By the associative property, we can choose which two things we want to multiply together first, multiply those together, and then we can work with the next thing that comes after that. So I'm looking at this. I have three things multiplying together. I'm going to choose to multiply 2x and negative 7y together. If you're able to multiply all three things together at the exact same time, great, go for it. But I'm just going to choose to do two at a time here because I don't want to rush myself. So I have negative 2x times negative 7y, or I have 2x times negative 7y, I should say. So working with the numbers, 2 times negative 7, it's going to give me a negative 14. X times y, again, I can't do anything else with those other than say xy in there. I've done nothing to the 3x on the outside over here, so it's just going to come down exactly as it was. We're going to deal with it in this step now. So now I just have two things multiplying together. Great. Work with each of these parts kind of, again, piece by piece. Work with the numbers. Negative 14 times 3. I believe it's going to give us a negative 42. Let me check that with the calculator because mental math. Yes, it's going to give us a negative 42. So working with the numbers first. Negative 42. I have x here and x here. X times x is the same as saying x squared. So simplify that down to being x squared. And I have a y left over in there, and it's also multiplying with everything, but there's no additional y's that show up, so it's just going to come along for the ride. Let me write it down as negative 42 x squared y. Sorry, just move my mouse around there. Bumping into it with my arm. And I can't do anything else, so I'm going to leave my final answer written out like this. So again, the big part of this section is getting used to the part of we are going to have variables in our final answer. We are going to have things that are a little bit unconventional from what we have been seeing up to this point in time, but there's nothing wrong with that based on what we've been asked to do and the values and things that we have been given in the problem. So our next example that we have here this is our third one, again from the same set. So I have negative 5 times the quantity 3c minus 4t plus 9z. We have PEMDAS. There we go. So I'm looking inside my set of parentheses, and I'm saying, can I simplify anything inside here? And I can't. One's a C term, one is a T term, and one is a Z term. So I cannot combine those things together at all. They're different variables or different values. I cannot combine any like terms in there. Okay, so my parentheses are done. I have no exponents, so that's done. Multiplication or division. I have this negative 5 out front here. And it's being multiplied by a whole bunch of stuff inside a set of parentheses. So this is where we're going to apply the distributive property. So this negative 5 is going to multiply through to everything inside the set of parentheses. Now I'm going to write an intermediate step here of everything being multiplied by negative 5. You do not have to do this. If you can keep track of how things multiply together in your head, great. I want to write this out just to make sure we all know how we're getting to the answers that we are. So again, this negative 5 is going through to everything inside there. Looking at the first two terms that we have, the first thing that's multiplying together, negative 5 times 3c, it's going to give me negative 15c. Better 15. There we go. Looking at our second term, I have a negative 5. So I'm going to rewrite that to be a positive here. I don't want that double sign showing up. And again, that double sign is showing up right here. We don't like that. I'm just getting rid of that from one line to the next. This is, again, me taking some extra steps to get this filled out. You do not have to do this. If you can take care of all this in your head, that's fine. And then our last term that we have, again, we've got double signs showing up. We've got a positive, negative. I want to just make that a single sign. So a positive times a negative is going to be a negative. Just get rid of that double sign there. And now from here, multiply the last of the things out. I've got 5 times 4t, which is going to give me 20t. And negative 5 times 9z is going to give me 45z. Okay. Once again, I still can't combine anything because they are different variables. One's a c, one's a t, one's a z. I can't do anything else. I've got my final answer there. Again, no other multiplication, division, no other addition, subtraction, so I'm done. And we'll take a look at our last example that we have here, number 4. It's kind of lagging a little bit here for me. Okay. 7. Okay. Now, this is a bit more like the previous chapters we've been seeing in terms of we've had, we don't have any variables showing up. We're just using PEMDAS in this scenario. And this does mean that, again, we can still have stuff just like we saw previously showing up. There's nothing wrong with that. It just ends up being the case that now, based on our previous 3 examples, sometimes we're going to have variables showing up, and that's fine. And sometimes, looking at this one, we might not have variables showing up, which is also fine. Okay? But again, whichever scenario that we're starting with, we're going to be using PEMDAS to simplify this down even further, or to simplify this whole thing down. So following that, PEMDAS, can I do anything inside the parentheses? Yes, I can. I can do 6 minus 7 plus 8. So when I combine those together, 6 minus 7 is going to give me negative 1 plus 8. And then negative 1 plus 8, that's going to give me 7. So my parentheses are done. I have no exponents. I have multiplication going on. Negative 10 times 7. Negative times a positive is going to be a negative answer. 10 times 7 is going to give me 70. And I'm done. Okay. So we have, again, just general idea, the general process of going through these things. We're just using PEMDAS to go through and solve these. Not a whole lot else is really changing. Again, the only difference now is that we can have variables in our final answer. Okay. So again, not a whole lot else we really go through on this front. There are more examples that we can go through otherwise, but I do not want to take up a whole bunch of extra time if it is not necessary. So I am going to end the recording there because again, there's not much more, not much else to go through these other than just further examples as necessary. So I'm going to end the recording here, and I'll take any questions that you guys have over this and go from there.